Hello and welcome. Our task in this question is to find the value of x. So what I'll do first is, because I want the base to match on both sides, so what I'll do is to change the base of log to base 9 of parenthesis 6x squared minus 19x plus 2 to base 3. And I'm going to use one of the properties of logarithms, to achieve that. And that is a property which states that if we have log to base a exponent x of b, this will be equals to 1 over x log to base a of b. So which means for log to base 9 of parenthesis 6x squared minus 19x plus 2, okay, this is same as log to base 3 raised to the power of 2. When we write 9 in terms of base 3, that is 3 times 3. That will be 3 squared, okay? And 3 squared is 9. So of parenthesis 6x squared minus 19x plus 2. So now we can apply the statement that log to base a exponent x of b is equals to 1 over x log to base a of b. So here we have log to base 3 exponent 2 of parenthesis 6x squared minus 19x plus 2. So that will be, which means log to base 9 of parenthesis 6x squared minus 19x plus 2 will be equals to 1/2 of, that is 1/2 of log to base 3, okay, of parenthesis 6x squared minus 19 plus 2. So which means the equation will now be, now for the left hand side we have log to base 3 of 2 minus 3x, and this will be equals to, we have this to be 1 over 2 log to base 3 of parenthesis 6x squared minus 19x plus 2. Now to get rid of 1 over 2, I'm going to multiply this equation by 2. So which means 2 multiplied by log to base 3 of parenthesis 2 minus 3x. This will be 2 log to base 3 of parenthesis 2 minus 3x. And this is equals to 2 multiplied by 1/2 of log to base 3 of parenthesis 6x squared minus 19x plus 2. Now 2 will cancel 2. So we have 2 log to base 3 of parenthesis 2 minus 3x, and this will be equals to log to base 3 of parenthesis 6x squared minus 19x plus 2. Okay, so now this multiplier, okay, I'm going to bring it here to become the power of the argument. That's the argument parenthesis 2 minus 3x. All right, so this will be log to base 3 of parenthesis 2 minus 3x raised to the power of 2. Then this will be equals to log to base 3 of parenthesis 6x squared minus 19x plus 2. So we have log to base 3 of this equals to log to base 3 of this. Now let's not forget that the property I apply in this case is that if we have log to base a of p raised to the power of n, this will be equals to n log to base a of p. Okay, so now in this case, I'm going to extract this log so that we can have parenthesis 2 minus 3x raised to the power of 2. And this will be equals to 6x squared minus 19x plus 2. Okay, now I'm going to expand this on the left hand side, and this will be 4 minus 12x plus 9x squared. That is the expansion of square of 2 minus 3x. All right, then on the right hand side is, we have 6x squared, okay, minus 19x plus 2. Now I'm going to collect like terms. Okay, now I'm going to carry everything on the right hand side over to the left hand side. So I'm going to put this first. So this will be 9x squared. So when this 6x squared, okay, is as in when the 6x squared crosses over to the left hand side, it will become minus 6x squared. Then we have here we have minus 12x. Then I'm going to carry this minus 19x over to the left hand side. Then it will become plus 19x. Okay, then also we have 4 on the left hand side. Then I'm going to carry this 2 on the right hand side over to the left hand side to become minus 2. Then everything will be equals to 0. All right, so 9x squared minus 6x squared. This will be 3x squared minus 12x plus 19x. This will be 7x. 4 minus 2, that will be 2. So here we have a quadratic equation. So to solve this quadratic equation, okay, I'm going to make use of method of factorization by splitting the middle term. And the two factors of now our product of root, which is 3 times 2, that's 6, okay, that multiply, to get 6 to what? The two factors are multiplied to 6, and when added will give us 7. That will be 6 and 1. So this will be 3x squared plus 6x plus 1x plus 2 equals to 0. Okay, all right. So in this case, I'm going to divide this pair by 3x. So which means 3x squared divided by 3x. This will be x. Then 6x divided by 3x. This will be plus 2. Okay, then plus 1 parenthesis x plus 2 equals to 0. So that 3x plus 1 multiplied by x plus 2 will be equals to 0. Okay, now I'm going to set each of these equals to 0. So the first one is 3x plus 1. This will be equals to 0. And also we have or x plus 2 is also equals to 0. So the value of x, the first value of x will be minus 1 over 3. And also the second value of x will be negative 2. So we have x to be equals to minus 1 over 3. And also we have x to be equals to minus 2. Okay, now this is very important. We can always check for extraneous solution because the argument of a logarithm must always be positive. That means it must be greater than 0. So to check for extraneous solution, let's check if our argument is greater than 0, okay? Or that is to check if our argument will be positive. So now let's checking for extraneous solutions. Now we have x. Okay, let me write the equation. We have log₂ base 3 parenthesis 2 minus 3x. Okay, 2 minus 3x. Now when x is equals to minus 1 over 3, are we going to get, is the argument going to be positive? The answer will be, what that is, let's find out. So we have log₂ base 3 of 2 minus 3 multiplied by 1 over 3. Okay, let me use a square bracket. So this will be negative 3 times minus 1 over 3. That will be plus 1. So this will be log₂ base 3 of 2 plus 1. And this is what? Log₂ base 3 of 3. And this will be equals to 1. So we have here that the argument is 1. Now this is the left hand side. Okay, this is the left hand side. Okay, now let's check if the argument will be positive, okay, on the right hand side. And let's not forget that log₂ base 9 of parenthesis 6x squared minus 19x plus 2 is same as 1/2 of log₂ base 3 of 6x squared minus 19x plus 2. So we have that the right hand side, which is log₂ base 9 of parenthesis 6x squared minus 19x plus 2, which is same thing as 1 over 2 log to base 3. Okay, now I'm going to plug in the value of x, which is minus 1 over 3. So this will be 6 multiplied by minus 1 over 3 raised to the power of 2. Okay, then minus 19 multiplied by minus 1 over 3, then plus 2. Okay, let me continue. Okay, let me continue from here. So now from there we have that this will be 1/2 of log to base 3. Now square of minus 1 over 3, that will be 1 over 9. So we have this to be 6 multiplied by 1 over 9, then minus 19 multiplied by minus 1 over 3. This will be plus 19 over 3, then plus 2. Okay, even from here, we can see that the argument is positive, but let's still find out if we're going to get the value to be, as in the right-hand side to be 1. All right, so now let me divide this by 3. Dividing this by 3, I'll get 2. 9 divided by 3, this will be 3. Okay, so that this will be 1/2 of log to base 3 of 2 times 1. This is 2 over 3 plus 19 over 3. This is 2 over 1. So 3 times 2, this will be 6 over 3 as well. So that this will be log to base 3 of, so I'm going to add, we have this to be 2 plus 19, that's 21. 21 plus 6, this will be 27 over 3, common denominator. Then I'm going to bring the multiplier, okay, here to become the power. Okay, so now 27 divided by 3 is 9. So that we're going to have log to base 3 of 9 raised to the power of 1 over 2. And this same thing as square root of 9. So which means that this will be log to base 3 of 3. And that will be equals to 1. Let's not forget that 9 raised to the power of 1/2 is the same thing as square root of 9, and that equals to 3. Okay, so which means the right hand side is also equals to 1. But when checking for extraneous solution, we want to be sure that the argument of the logarithm is what? Positive or greater than 0. Okay, and we already know that it is positive based on the information we have here and also here. All right, so when the value of x, so which means x equals to minus 1 over 3 is a solution. Okay, now when x is equals to minus 2, so we have that the left hand side, okay, which is log to base 3 of parentheses 2 minus 3x, okay, will it be equals to log to base 9 of parentheses 6x squared minus 19x plus 2. Now again, I'm going to use 1/2 of log to base 3. That is this guy. I'm going to use 1/2 in this case after changing the base on the right hand side to 3. So when x equals to minus 2, now the left hand side will be log to base 3 of parentheses 2 minus 3 times minus 2. Okay, now will it be equals to, this will be 1/2 of log to base 3, open square bracket, 6 multiplied by minus 2, then all raised to the power of 2, minus 19 multiplied by negative 2 plus 2. Okay, so in this case, minus 3 times minus 2, that will be plus 6. 6 plus 2, that will be 8. So the left hand side is log to base 3 of 8. Now, is this the same as the right hand side? So we have on the right hand side 1/2 of log to base 3 of square of minus 2. That's minus 2 raised to the power of 2 is 4. 4 times 6, this will be 24. minus 2 times minus 19. That will be plus 38. Okay, then plus 2. Okay, so this will be 40. 40 plus 24. That will be 64. So we still have log₂ base 3 of 8 on the left hand side, so that this will be log₂ base 3 of 64. Then this multiplier will come here to become 1/2. That is the power of the argument. Now 64, okay, raised to the power of 1/2 is the same thing as square root of 64, and that's 8. All right, so in this case, we can say that log₂ base 3 of 8 on the left hand side will be equals to square root of 64 is what? 8. It also equals to log₂ base 3. The right hand side is also equals to log₂ base 3 of 8. So which means that the left hand side, okay, is equals to the right hand side. So it means that we can say that x equals to minus 1/3 and x equals to minus 1/2 are the solution to this problem. The noblest pleasure is the joy of understanding. Bye-bye.